Hi students, this is Mr. Yao. Today we're going to talk about 5.6a, where we will review and learn a little bit more about isosceles and equilateral triangles. First, let's review the definition of isosceles triangle. It is a triangle that have at least two congruent sides. Since it says at least, that means if a triangle has three congruent sides, which is an equilateral triangle, that still is an isosceles triangle. And we have some names for each part. The two congruent sides, they're called legs. And the third one is called the base. The angle formed by the legs, which is on the top, this one, that's called the vertical over the vertex angle. And the angle formed by the leg and at the bottom, that's called the base angle. So these two are called the base angles. Then we have two theorems. First, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides. So opposite those sides, that's opposite, and that's opposite. These two angles are also congruent. That is isosceles triangle theorem. We also have the converse of isosceles triangle. In this case, we just kind of reverse the order. This one we know the sides, then it's going to angle, so the converse is going knowing the angle, going to the sides. If two angles of the triangle are congruent, then the sides opposite those angles are congruent as well. So now let's have a look and write some statements. If HG is congruent with HK, we just look for which angles are actually opposite them. That one is the opposite, and that one is the opposite. And G is actually HGK. That's the first angle, is congruent with HKG. Again, we go from the outside points. The actual angle point is in the middle. Next, if KHJ, angle KHJ, which is right here, is congruent with angle KJH, then the opposite would be, that is the side opposite to it, that's the side opposite to it. So we got HK is congruent to KJ. These are some statement practice. Next, we can classify triangles by their size. A scalene triangle has exactly 0 congruent angles. That is like a regular triangle that we see, like that one, for example. That's a normal triangle, there's no congruent sides. Isosceles triangles, that is when a triangle has exactly 2 congruent legs. And of course, here is all 3 legs are congruent. If all 3 legs are congruent, that means all 3 angles are the same. So these angles, they're all 60-degree angles. Now let's use these definitions and vocab to do some practice. Example number 1. These 2 lines are being marked as congruent, which means these 2 angles are congruent. And since all the angles inside a triangle is 180, that means x plus 28 is 100. After solving, x should actually be 152 divided by 2. That is 76. That's number 1. Number 2. These 2 are being labeled, so we know this angle must be, if they're 50, we have 50 plus 50 plus x 80, x 80. Then the other side, we have y, and since these 2 sides are the same, y plus y 100, 180, y equals 40. That's example 2. Example 3. If this is 110, since that entry angle, we know this is 70 degrees. And if these 2 sides are congruent, that means it must mean y is 70 degrees. Well, actually, y is 70. It already has it. And then we know 2 70s, that's an x, so 70 plus x is 180, or x equals 40. That's example 3. Next, example 4. We have quite a few angles we need to find. First, we see these 3 are being marked the same. That means these angles are 60 degrees. Next, since that angle is 50 and these 2 sides are the same, that means I can call that x, then this will be x. 50 plus x plus x. That's 180. x is 40, x is 65. So these are 60. Let's have a look and complete the blanks, the questions. BCA, right here, that is 60 degrees. DCE, that's right there, 65. DEF, that one is supplementary with 65, so it's going to be 115 degrees. BCD, this one, we see 60, 65, and they're making a straight angle. So 60 plus 65 plus, let's call that y, 180. After solving, our y should actually be 55 degrees. EAD, that is outside the 60 degrees, so that is 120 degrees. And GAH, the vertical angle with the 60 degrees, so it's 60 degrees. That's example 4. Example 5. They're the same, so that is y. And the same, so that is 55. Plus 55 plus x is 180. X should be 70, which means this vertical angle is 70. So y plus y, 70 is 180. Y is 55. That's example 5. Example 6. Find m and n. First, before we do anything else, these two sides are the same, so these two angles must be the same. And also, we see these two sides are the same, the inside. These two sides are the same, so these two angles must be the same. That means that is also n. So we have n plus n plus 80, 180, and then we see this m plus n, this whole thing. I'm just going to call that x, this whole thing. If the whole thing is x plus x plus 50, so x would have to be 65. But I'm looking for m. M is x take away the n, which is 45. So m 65 minus 45, which is 20. That's example 6. Next, we do have two proofs. We're going to prove this theorem and its converse. The first one, prove isosceles triangle theorem. If the two sides are the same, we're trying to prove the two angles are actually the same. Normally, we don't even have this middle line. That is an auxiliary line that we made. So the first two steps are given. Take m as the midpoint. So if m is the midpoint, we know these two are the same. And that's by the definition of midpoint. And then we're going to connect this j and m. That is something that's new. I don't think I'm going to put that on, like, quiz you on that, but it kind of makes sense. 2 points determine a line. We do need 2 points to actually make up one line. So there's that. And next step. If we want to prove it, you can clearly see we have side. The other side is the same. They also share the side. That's why we're going to use triangle congruence to actually prove it. So moving on. MK is the same as KL. That is by the definition of midpoint. Because we have the midpoint, so these two parts are the same, they're congruent. Step 4, which is given, that's right here, J is congruent with JL. So we have two pairs of lines right now. Next one is reflexive property, and we see this JM, the middle line, the shared line, is congruent to itself. So now, next, we have side, side, side. Step 6, we can say these two triangles are congruent. That's by side, side congruence. After that, since these two triangles are congruent, we can know K and L, these two angles are the same. So angle K and angle L are the same. That is by CPCTC, which stands for corresponding parts of congruent triangles are congruent. That's number 7. Now, last example, which is the proof for the converse is isosceles triangle theorem. So this time we know the angles are the same. We're trying to prove the sides are the same. First, we're going to draw an angle bisector because we want to force congruent triangles. So now in angle, we know a shared line. So we basically have A and S. If we actually want to prove it, we either need another S or another A. Another S is kind of hard to get. We don't know this one. We don't know that one. And besides, if we actually do that side angle, which we can't use. That's why we need this angle, and that's why we draw the angle bisector. So BY is the angle bisector of the angle B. After that, we know angle ABY is congruent to CBY. These two angles I just labeled. That's by the definition of angle bisector. Next, we know angle A and angle C are congruent. That is given. So now we have two pairs of angles. We need a side. And BY is being shared, so that's reflexive property. And we have angle, side congruence. So now know the triangles are congruent. We can conclude AB and BC are congruent. That again is by CPCTC, which stands for corresponding parts of congruent triangles are congruent. That is everything for 5.6a. Thank you.